Hello and welcome to episode 9 of the Confounded Chronicles. In this video, we're going to show kind of how I built the Here it is. At the end of the video, we'll go ahead and assemble that. This is the prototype, the first version of the Mark III. It's not all the components. I still have to build a pocket clip. That's a whole mess of work. It's currently Friday night. I upload Friday morning, so I'm already time late, and I'm still editing video. So we'll have this up Friday night. I want to get this condensed together, and then we can work on the pocket clip, and that'll probably be next week's episode. Well, it will be, because I have to get it done. And yeah, so anyways, today we're going to go through the process of how I built most of the components, and we'll put it together at the end, and that's where we'll be. So the part we're making here is the tail cap. This is made out of 316 stainless. Basically everything on the pen is 316 except the grips. Those are brass, obviously. And I used a combination of insert tooling and high-speed steel tooling. High-speed steel tooling is probably better for this size of lathe, but I just don't think my grinds were perfect for stainless. I'm still kind of learning on how to grind properly for stainless. So the insert tooling gave me a little bit better surface finish in most of these instances. I think I'm taking about 10 or 15 thou off per pass here, just to get the bore sized, or the tip size there, correct for threading. So once we've got the bulk of the material off, we're going to drop the high-speed steel tooling in and clean up that corner just to get it nice and sharp. And then we're going to take and break the edges just to make the die slide on a lot easier. So next up, I'm going to use my new custom die holder here. And this was actually something I had to make this week because I was having all kinds of issues. I had a crappy die holder that was actually expanding under load and changing the diameter of my threads, which didn't work when I went to put it into a tapped hole. So what this is just basically a big block of aluminum. It's got a big handle on it from one of my mill handles that I don't use right now. The die drops in there. It's already bore sized to however I want it for that specific die. The little brass screw on the back locks the die in place. And the handle lets me take up some of the cutting load. So I'm not transmitting it directly through the tailstock of this lathe. It's just not really a beefy tailstock, and threading stainless takes a decent amount of force. So I just wanted a way where I could mitigate the amount of force that I'm putting through to the tailstock. And it works amazingly well. It keeps everything concentric. It keeps the die face aligned perfectly. I bored it so the die actually sticks out further so that it bottoms on the wherever my end of threading is, so I can cut right as far as possible. And yeah, I was incredibly happy with it. It works super well, and it keeps the die from expanding, which was the problem in the first place. So I should have built this years ago, but I'm very glad I did. The die cuts that I made for these threads are actually a lot better than I thought they were. I thought I was going to have kind of galling issues with the stainless, but no, it cut beautifully well. I mean, those are expensive dies, but they work really well. Next up, we're going to make the grip. So we're going to part the end off and just have a nice clean face to work with. And then we're going to drill with center point it first, or center drill it, and then we'll go with a big 3/8 to hog out most of the material. This brass is a little bit more stringy, so I'm wondering if it has some more bronze in it than it does brass. Typically brass chips away really nice. This was out of a scrap bin, so I'm not entirely sure what grade of brass it was, or even if it is brass or more of a bronze or whatnot. Next we use a boring bar. Once again, carbide, just makes life a little bit easier. Doesn't matter at all with brass, but with stainless it made a bit of a difference in my opinion, or in my case here. And we're going to size it so it's just a little bit over the diameter of the pen body, so we get a nice slip fit without a bunch of slop. And here we're just going to bore all the way down to the end as far as we can, and then we'll part it off and use it as such. At this point, I realized my camera battery was getting quite low, so I missed the wonderful parting off operation. Like now. You have to take my word on it. It went fine. Next up, I want to make the locking rings, and to make the locking rings, I have to cut some grooves around the part. What I chose to do that with was a ball end mill, and putting it on my index jig in the lathe. You can see I've now aligned all my parts. I aligned the vise, and I aligned the 4th axis up, and got everything dialed in correctly. And here we're basically just going to bring the end mill down to the top of the part, and take a section off the part. It's manually CNC controlled. Initially, I am going to write a program for this, but initially I'm just using the jog keys on the keyboard to drive the mill across at a fixed speed. I used FS Wizard to get my feed rate. I'm still kind of going between that and G Wizard. I used the trial of G Wizard, use that up, and trying FS Wizard now here, which is free, and a lot of people seem to like it. So it seemed to work, generated a chip that I was quite happy with, and produced a really nice cut. The air blast would have been best for this. I was just seeing how coolant worked or how oil worked on this cut, and it seemed to work fine. The chip load was so small, and there's so much room when you're cutting with a ball end mill that I didn't have too much recutting issues. So Went around the part, and we got 6 little flutes along it, and that'll like give me enough room now to cut all the locking pins for a few of the prototype pens here, without having to go back and do this process over again. After I got the ends cut, I basically have to bore these locking rods out to the correct size. So I'm just going to use a drill bit to get majority of the material out of the way, as a drill is kind of the fastest way to get material out of the way. These are those cobalt parabolic flute bits, and they work amazingly well. I'm incredibly impressed on how well they can go through that stainless. I was kind of concerned deep drilling some of the stainless, but no issue at all. Once again, using the boring bar to size it for tap size. I could use a drill for this tap. I just didn't buy a drill for this. I decided to use a boring bar. I like the concentricity of a boring bar, so we went that way. And here I have the tap set in the lathe. The little Jacob's chuck there just doesn't have the muscle to hold that tap, so I use it basically just to get it as straight as I possibly can. And then I'll use a tap holder with a brass center in the little Jacob's chuck and put it in the end of the tap. Just try to keep everything concentric, and the tap handle will rest against the little aluminum support on the back of my lathe there. And I can just thread by advancing the spindle. So that works amazingly well. Once again, those spiral flute taps cut like no other. Like 25% of the force that I use with my old plug taps, or 3 flute taps, or whatever your standard generic cheap tap is. So that got us to this point. All the components go on quite nice, and I'm super happy with it. So in the next little segment here, we'll go ahead and assemble this pen. You can see what it looks like. So the main components we have are the body, which has a bunch of subcomponents here. So it has the locking rings, front and rear. It has the tail cap, which this one isn't drilled for the magnet hole yet, but will be. And then we have the tip, and these are the ones I'll be able to switch out to accommodate different refills and different bore diameters. We have the 2 grips, which these ones are just going to be brass. Nothing is polished on these yet. These are just basically right off the lathe. Like I said, it's my prototype. It's what I'm going to carry around. We got the pen, ink, the Parker refill, spring. We also have the cap, and then we have the pocket clip securing section. And when these go together, that's where the pocket clip is going to sit, and it's going to be stainless and be bent along here. But that's part I have to make yet, so that sits unfinished. But the whole pen goes together. It's I made it so it's flippable, floppable. Grips are the same size, so they go in either which way. I wanted them to fit with just a nice amount of tolerance, so they slide on nicely without wobbling around. And they're sized to just be a little bit over the threaded length. That way, when these little locking rings go on, they bite tight against the brass and keep everything nice and snug. I guess you could run these loose too, and be able to play with these. I probably will end up Loctiting these in place, with just maybe even just like a temporary Loctite or non-permanent, just to keep everything nice and snug. I don't know yet. Maybe not. Maybe I'll leave that up to the end user. I don't know. We'll see. I'll have to play with it and carry it for a bit and then see what comes of it. So those both go on. You pick your end, whatever you want for the cap, or the tip, I should say. Both ends, once again, are threaded, so it works. And everything, or every little side, is counterbored as well, so the threads fit nicely. Because the way I make my threads, I don't do single point threading because my lathe doesn't have the ability to do single point threading. So everything has to be tap or die cut, and as such, I can't get all the way to the end. So I machine a little clearance here, and then I just put a counterbore in the threaded end as well, just for kind of a belt and suspenders way to go about it. But that way you'll never have jamming, and it'll always be made up nice and tight. That goes in, pen, ink goes in, spring goes in the back. This tail cap I'm probably going to change slightly because this spring actually registers decently nice on the tip of the Parker style refills, but it doesn't register very nicely against the stainless steel back here. So what I'll probably do is turn this tip, once again this tip kind of has a basically non-threaded section, which will be longer on the other units, just so I don't have to thread so much and so you don't have to unscrew it so far to get it out. But what that'll do is it'll be sized to fit inside that spring, so everything will be held nice and concentrically. Doesn't matter at all, but it feels better when you're putting it together if the spring kind of mates up with this cap a lot better. So otherwise you're kind of fighting it. Kind of wants to jump into threads and it gets annoying. So that tightens up like that. This part I might also make bigger because this is a very hard part to hold in the lathe. I mean, I have a 5C collet in the lathe, which is awesome because I can grip this part quite nice. But to grip it and then still put a chamfer on that inside edge, and then to come in with a tooling to cut the basically thread relief, it's very tight to the cone of the lathe. And I might have to grind some specialty tooling or some different tooling to get in there and make my clearances, or make this longer. I don't know. I might make it longer. I don't know yet. I'm going to carry it for a bit and decide. So that's the pen. Then the cap. It goes on the front. This cap was actually made pretty crappy-ishly. When I initially built this pen, I was chasing down some tolerance issues. I couldn't figure out why my threaded section wouldn't fit into the cap. I addressed that earlier in the video. It's because of the die expansion. So I ended up machining these threads down because I thought maybe maybe my tolerances were just a little bit too tight for the threads to mate correctly. So I ended up cutting these threads down with the boring tool, and it just made for a really sloppy fit. So once again, this is my pen, my prototype. I don't care because I'm going to carry it, but you can see this one has some, once it's tight, it doesn't play. So I got to work that out, but it's not an issue going forward because I figured out why that happens. So anyways, caps, tail cap on the end. Nice. Once again, see, like that, it just doesn't sit right with those threads not cut perfectly. So let's try to pretend it's perfect. Anyways, feels nice in the hand. It is super weighty. If you're not a fan of heavy pens, oh, this is not the beast for you. I haven't weighed this yet, but it's 3-4 ounces. It's like my old, well, this was the very first one I made, but this is aluminum, super light. And then my mark, there we go. Here's a Mark II, and that's, I think, 2 ounces. This is probably 4 ounces, if not more. She's a tank of a pen, but right. This all off here. Right, nice. Yay. The one thing that I've noticed on this pen, where my clearances, my spring, and things from real world to CAD didn't translate perfectly, but there's more than enough tension to hold this ink. Like, you can write as hard as you want without it collapsing. I don't know, I kind of almost like that feature. That's initially what I tried to build with my old Mark I design. I wanted the refill to retract while you were, if you dropped it, tip down. And this one does it. Kind of like right out of the CAD model. I adjusted the back a little bit to bring that spring tighter. I don't know, should I leave that in as a, like, you're literally never gonna press on it hard enough when you're writing. Like, when you're writing, it's no issue at all. But I don't know, when you drop it, I don't know, it's not gonna protect it, but it's fun to play with. I don't know. I might work it in or out of the design. I don't know yet. I'm gonna have to, once again, test with it for a while. Some of the beta units going out, I have a few people that kind of are my testers and whatnot. They're gonna have different varying states of this pen, just because I like to test it and I like to know what works best. But yeah, I don't know. That's that. That's her so far. I'm happy with it. So that covers this week's video. I'm gonna finish editing it and then I'm gonna upload it right now, so you guys can all watch this. And then basically I'm going to jump right back into CAD because I have to start CADing up a fixture to hold the stainless steel plate down to do the pocket clips. Pocket clips are designed. I'm happy with them. You can see obviously in the last video there's a rendering of it, so they're finished. But I got to figure out a way to machine that 50 thou stainless without it lifting, and basically I'm gonna make a fixture and hold it down. But next video, tune in next time. It'll be done hopefully, and we'll go from there. So thanks so much for watching. I'll see you guys next time. Adios. Bye.